Share. All right, can everybody see my screen? You should be looking at Canvas. Very good. All right, so quick catch up on where we are. Last week we finished up topic 2, which is program design overview, how to set up your program, and we took a look at the meal maker sample project. We'll revisit that later in the semester as we get into certain diagrams and talk about how different entities within the program interact and relate to one another. All right, so today we are going to begin the SDLC, which is the software design lifecycle, and look at system analysis, where we're kind of evaluating software development and thinking about the right kind of things that we need to think about is what we've got going on. Assignments that you have coming up. Today is the 24th. On Friday, you've got 2 things due. You have your quiz, which is going to be on the topics that we're going to cover today, and you have your project proposal due. Let me get this. All right. Let's take a look at the quiz first. Quiz is relatively straightforward. In fact, I'm going to push the due date of this to Sunday. Due date. Because I don't know. I don't think we'll get through the entire topic outline today. I think we'll have to finish it on Thursday, and that way you guys have more than one day to take the quiz. We'll finish the content that you need for the quiz on the 26th, and then you'll have a couple days to take the quiz. It's short. All of the quizzes are 5 questions or fewer. They're open note, and so you're welcome to use whatever resources you need to take them. They are more of just a check to make sure you understand there. And remember, I drop the lowest quiz. As far as your milestone, which will stay due on Friday, it's pretty simple. We need a 1-page, less than 1 page document that simply outlines your project. And specifically, here's how it's going to be graded. These are the 2 things that the grader is going to be looking for. The first is a description of the project. This is what I'm doing. This is what the program is going to do. And overview of the functions. These are the ways that the user can interact with the program. There's going to be some overlap between a description of the project and an overview of the functions. Because as you describe the program, you're naturally going to describe what it can do. Okay, and so as long as you describe it and you talk about what the program can do or how the user is going to interact with the program, you'll be totally fine. Okay. Any questions on either the quiz or this? The quiz is due Sunday. This is due Friday. Any questions on either of these? No, GUI is not required for the project. You're more than welcome to, and in some instances, it'll be easier to use GUI because dealing with input through a console only is challenging. And like if you've got a bunch of different options, it's a little bit annoying to type 3 to do this, where you could just have a button. Or if you're doing some sort of drop-down menu or an input field, it's obviously a little bit more work to set up GUI or to create the buttons and that sort of stuff. But it's overall, it's not easier to do it or not to do it. Some things are going to be easier. Some things are going to be more difficult. Okay, Colton, the quiz is multiple choice. Yes, multiple choice. All right. Any other questions on that?
I have a question.
Yeah.
So for this proposal, like if we put that we have certain functions that we want to do, but then later on as we like start to finish it, the project, can we still like add more functions or take some functions that we said in the proposal?
Yeah, you can. You guys are new to creating software. And so a lot of times you don't know what you don't know. And even when I plan out games, those design documents and those proposals are living. They change, they morph, stuff gets added here, stuff gets taken away from here. As long as you stick to the core idea, and so if you're doing your project proposal is somebody last semester did a tee time for golfing. It was a program that kept track of tee times. If you say you're going to do that, and say you're going to have these features, and then you end up doing most of those features, but you added one and took out one, that's totally fine. But if you say you're going to do a tee time organization project, and you turn in something that has to do with a house cleaning schedule, that's a problem. Like it needs to relatively adhere to your original proposal, if that makes sense.
Okay, thank you.
You're welcome. Other questions on this? Okie dokie. All right, well, let's hop over to modules and let's get into software design life cycle. Okay, so what we're looking at these next couple of days is different approaches to creating software in terms of like start to finish the planning process to the actual design and testing and going back and fixing stuff and changing stuff, and then the actual deployment of it. And this should line up roughly with where you guys are in the development of your software. And I tried to set it up that way so you guys had the right information at the right time. But this includes all the activities that relate to the analysis, which is trying to figure out what you need, thinking about what the program is going to do, thinking about the problem that's going to solve, and then designing it, the development or programming of it, testing, maintenance, and project management. All right, there are lots of different ways to approach creating software. My favorite is don't plan anything at all and just get right into coding. Don't actually do that. That's not a good idea. But when I first started, that's what I did. Like, who needs to plan stuff out? Let's just get to the fun stuff. You end up wasting a lot of time doing that, so don't do that. But there are a handful of steps in the process that you need to do. The order that these occur matter in terms of saving you time and headaches and effort. So here's generally the outline for how things need to be done. The first thing that you do is you're trying to identify whatever problem it is. And it doesn't have to be a problem in the sense that like the world is falling apart problem. It could be just something that can make your life easier. And so even if it's as simple as planning out meals, like that'd be nice if there was a tool to help me plan out meals. Okay, that's the problem. It takes too long and it takes too much effort, and I don't like planning out meals. Whatever the problem is, identify what it is, because you want to make sure the program matches up with the problem that you're solving. Okay, you need to plan and monitor the project. All right, this is kind of distributing who's doing what. In this semester, you guys are going to be doing it also. That this step is pretty easy. The discovery phase is related more to, and even the planning and the discovery phase, this is more a part of larger development projects where the development team, excuse me, isn't necessarily the ones familiar with the problem. And so if you think in banking or medical spaces, you might have a doctor or a banker need some sort of program to make their life easier. And the person actually coding the program isn't going to be super familiar with the situation that the doctor or the banker's in. And so they really need to spend time understanding what the problem is to make sure that the solution, the program, actually fixes that. Obviously, then you're going to design the system, you're going to build, test, and deploy. All right. Questions before we get started with the first example? Okay. First one. Our driveway alarm is going. Can y'all hear that? That chime in the background? We have an alarm on our driveway because we live on like a mini farm, and you can't see, there's a gate on the front of our property, and you can't see the driveway from our house. And so we have no idea if somebody's like at our gate. And so we have an alarm. It's a chime that plays whenever somebody's at our gate, and it's going off over and over again. All right, let's take a look at this first one. This is the old school style of software development. This is what they used to do way back in the day. And this is the waterfall method. You do one step at a time. You don't move on to the next step until the first step is completely finished. And if you notice, it's all downhill, one after another. And there's no backtracking. Like once we finish the requirements, we're never going back. This is, like I say, it's the old school way of doing it because it's not done like this so much nowadays, but it's important to know that this exists and this is a thing. So this is the waterfall method because it kind of looks like a waterfall. First, you get the requirements. This is what the program needs to do. Then you design it. And you kind of get the design okayed, and then you actually build it. You test it to make sure it did what it's supposed to do, or it does what it's supposed to do. And then you deploy it and you maintain it, fix bugs, make sure it's running smoothly, all that sort of stuff. And that's the basic process for the waterfall method. Okay. Questions on waterfall? Okay. I mean, there are different, how many of you have taken software engineering 3155? Miranda, what does that mean? All right, so for those of you that have taken software engineering, do you talk about the software design lifecycle, or you talk about different ways to approach software development? I don't exactly know what you do in that class. I've never taught it.
Can you hear me? Hello?
Yeah.
Okay, I was about to say, it's been like forever since it was like a couple semesters ago. So unfortunately, I don't really quite remember the content of the class.
I gotcha. Okay. So yeah, Agile. Okay. Agile is an iterative development process. I think, do we talk about Agile? I think we do. Yeah. It's the next one. We'll talk about that in just a second. waterfall, and this is back to somebody else, if waterfall is still prominent. It is in the sense that you need to follow this basic pattern. Like, obviously, you're not just going to dive right into coding. You need to know what you're doing, and you need to know the requirements. The main reason that the traditional waterfall method isn't used is because there's none of this. Okay. And what they found oftentimes is they might have the requirements like, okay, this is what the program needs to do. And then they design it and develop it. And then during the development or during the testing, they realize stuff that they didn't know back during this phase. And so they kind of have to go back and redo things. And if you've ever coded, or you've ever made a project larger scale, and if you haven't, you'll probably run into it this semester. As you are coding and testing your project, you're going to realize things and discover things that you wish you had known when you were designing it. You're like, oh man, I really should have set this up this way, or I should have had the program do this. And so what you get, and we're going to get to this in just a second, is the waterfall method is still prominent in the sense that these steps are still followed. The difference is nowadays you get a lot of mini waterfalls. So we're going to go through iterations where we just continue to cycle through and continue to reevaluate. That's kind of how it's still used today. But let's look at some others, and I think it'll kind of come full circle, and you'll understand a little bit better once we get down there, or once we get through the different ones. And so here's kind of a different approach to this, and it's best summarized in this graphic down here at the bottom. This is iterative development, or developing in iterations. And so if you look right here, you do some initial planning, and the initial planning is only ever done once, hence initial. And then what you do is you get into an iterative waterfall cycle. So you go through the planning and the requirements, analysis and design, and implementation, which is where the coding takes place. And then you test it, and then you evaluate, and then you continue to do this process over and over again until you end up with something that you like. All right. And so the idea here is really relying heavily on the fact that you as the developer and you as the person with the problem, all of those people haven't really spent enough time with the problem and solutions to understand all of the things that they need to know to solve the problem. And so as you go through and you plan out what you're going to do, and you do all of these, you discover new things. And the new things that you discover affect how you solve the problem, how you code it, how you set up the project, all that sort of thing. And so when you're testing and evaluating, it allows you to go back and continue to go into this loop of making adjustments, planning, and doing this over and over again until you end up with something you like, and then you release. Okay, that's kind of the idea with iterative development. Does that make sense? Okay. Now let's talk about agile development. What is gosh, I read a book. I don't have it here. There's a term that goes along with agile development. It's like a scrum was the meetings. There it goes again. Hold on, I'm looking through my audiobooks. There's a specific type of agile development. I have a lot of audiobooks. Okay, it's just called Scrum. It's a really good book. Here, I'm gonna pull it up on my phone so you can see it.
This is Audible.
Can y'all see this? That's really hard to see. Get really close. Focus camera. Is it easier to see back here? I'll just read it to you. It says Scrum, the art of doing twice the work in half the time. The author is Jeff Sutherland. It's a really good book. It outlines not only software development, but how to approach a lot of life situations using agile development, using this specific idea of Scrum. And this is, it's a good read if you are so inclined to do that. But here's what agile development is. And you guys have taken software engineering or are familiar with this. The reason it's called agile is that the idea is you should be flexible, able to pivot from one thing to another, hence agility, so that you can anticipate new requirements. And this grew out of the iterative design process that we looked at up here. And I mentioned this before. One of the main tenets or premises to agile development is the idea and understanding that neither the developer nor the customer really understands the system and what it needs to do until they really get into the development process. And so you start and you do a lot of things like rapid prototyping, which is kind of similar to this down here. And you make like quick iterations of examples and be like, all right, what about this? What about this? What about this? And it works really well in some aspects. The main drawback is you can sometimes lose focus. Like you don't want to be so flexible that you can pivot to anything that you spend all of your time pivoting and end up with something that is not at all what you wanted to start with. So it does take discipline, but this is a good way to approach it. We're not going to talk, we don't go super deep into this because this course isn't about software development. It's more about object-oriented design. And so we're just kind of touching on the basics here. But you do have to be aware of scope creep. And scope creep is a term, if you're not familiar with it, it's a term that refers to the size of your project or the scope of your project, what it is that you plan to accomplish, creeping or getting larger and larger and larger, or not necessarily getting larger, but shifting. And so if you're like, you know, here, I'm drawing the screen. We want to focus our project on this. Okay, so that's where your scope is. But over time, as people make suggestions, sometimes your scope grows. We're like, wouldn't it be cool if we added all of these features? And then now your scope's up here. And someone says, well, I think that's good, but we should really be focusing over here. And so you take that thing and you kind of shift it over here. Now you're talking about all this stuff. And then somebody makes another suggestion and now we're way over here. And so the scope or the focus of your project tends to move. And that's what you want to be careful of in an agile development system where you're so focused on being able to anticipate and handle new things that pop up. Okay. Questions, thoughts, comments on agile? Did you guys like agile when you did it? I like there were definitely a lot of attractions to Scrum. Yeah, and I didn't do it justice with my explanation there. One of the great things about Agile is how fast you can get things done. You don't waste time with a bunch of unnecessary meetings. It really streamlines a lot of processes and makes things like estimating how long it's going to take you to do it really accurate and really quick. And so a lot of the unique ways that they do things are very innovative and work really well. And so I would definitely suggest, if you guys have plans to go into being a developer full time, read that book or check it out, or at least do some reading on the idea of Scrum and what it was created to do. Excuse me, because like I said, it has applications all across the board. Make it yeah, I'll post it in. I'll just post it here. This is linked to it in Amazon. Cool. All right. Let's talk about these last couple. Rapid application development. The idea here is to not spend a bunch of time planning. Get the basic understanding of what you need. Excuse me. Like, big picture, what are we doing? And then you rapidly develop prototypes. Prototypes are functioning programs that give everyone a sense of what the final project program would look like. Okay, and so it's not going to have bells and whistles. It's not necessarily going to be coded in the most efficient way. It's going to be quick and dirty and just give the user an idea of what is possible, give the user an idea of what a full version would look like. And what you are avoiding in these situations, and well, I'll say this. I say this down here at the end after we cover the last two, but the actual implementation, I don't know why I'm yawning. The actual implementation is most likely going to be a mixture of these for what you're doing. If you work at a specific company and they are super set in their ways, they may adhere to specifically, we're doing Scrum, that's what they do, or we're doing Agile. But a lot of times you'll find that it's going to be a mixture of different approaches. Okay, it's not going to be exclusively one approach. They're going to mix elements from different approaches into their overall philosophy. So it's important to know. The idea with rapid application, when you use this, is when you perhaps have a client or a customer that isn't 100% sure what they want, or they may have a history of changing their mind or saying, this is what I want, and then, well, actually, I don't really like this. I think we should do this. Okay, so if they change their mind a lot, or they're not really sure what they want, this is really helpful, because what you want to avoid in those situations is going through a lengthy waterfall process, getting to the testing phase, and them saying, actually, no, that's not at all what I thought I wanted. And then you've wasted a lot of time. Okay, and so this is nice in the sense that you can get out really quick prototypes without spending all your time planning out this intricate system, because you're not sure if that intricate system is going to be what the user actually wants. All right. Once you have the prototype and they say, yes, this is the direction you go, then you spend more time planning and properly developing it. You guys have been coding long enough to know that coding the right way takes a little bit more time, but you can get things done really quickly if you code with bad habits, like just make everything public and that sort of thing. So if you're not worried about like the long-term use of a program, you can knock out some prototypes pretty quickly. And so that's where that comes into play. Questions on number 4? Okay. Last one that we're going to look at, joint application development. This is pretty simple, and this is getting more and more common because so often the customer, the user of the program, oftentimes doesn't communicate well what they want or need in terms of fixing a problem. And it creates a lot of miscommunication and wasted time. And so joint application development takes the user and the developer and puts them together through both the design and the development process to avoid unnecessary or incorrect work being done. And so the way this typically works is you might have, they might get together and kind of design what it needs to do. This is also used in situations where the developer of the program might not have a lot of working knowledge about what the program needs to do, in the sense of it's got a lot of like trade secret kind of stuff or industry specific information, terminologies that may not be commonly used outside of that profession. And so like if it's a medical situation, or we talked about banking earlier, and there's a lot of really confusing things that you would only understand if you were a professional in that field, then this really comes into play, because it sure beats a lot of email questions like, oh, I don't really know what this is, let me email, and then you got to wait to hear back before you can continue working. And so if you have these dedicated workshops where they spend specific time or dedicated time working together, they can knock out all of these things. And then they come back after they've got a small prototype working and work through it that way. So again, a lot of these are mixtures. So you can do agile development and joint application together, or you can knock out, rapid prototypes in an iterative development setting as well. Okay, so that's kind of the idea between the two there, and you can do a lot of cool things in that regard. Okay, questions for me on this stuff? Everybody good? Okay, let me see what we've got left. Maybe we can finish today. It's going faster than normal. All right, maybe we'll plan on finishing today and won't need to meet on Thursday. Well, let's see what we've got going on. Let's pause here for a second. Let me go back to modules and see what's after this. Okay. All right, let's go ahead and finish today with this. We'll leave the due dates where they are for the other assignments, but we can finish. So we just went over a rough overview of the software design process, the life cycle, and we looked at different approaches from waterfall to iterative to agile and some others in between. We're going to shift and look at the analysis. And what we're doing here is, this is kind of how we analyze a problem and formally define what the system needs to do in terms of requirements and that sort of thing. Okay. So once you figure out what your topic is, and so if you know you're doing a meal planning program like we've looked at, or you know you're going to do some sort of weather app or an inventory for your closet, or whatever it is that you're going to do, once you decide on your topic, these are the next steps that you need to do. Okay. So first part, we're going to gather detailed information. So the way this works is pretty simple. You need to talk to or interact with the people using the system. For this class, it's going to be you most likely. If you are designing something for somebody else, so maybe a friend, a sibling, a parent, whatever, talk to them about what they need it to do. Describe and say, okay, if the program does this, this, and this, does that solve the problem? Also, you can look at programs that exist already that do similar things, or have similar layouts or functionality or that sort of thing. Gathering detailed information is the very first thing. Then you need to get into your requirements, and you need to know the stuff. You're going to have quiz questions on these. There are two types of requirements. You have functional requirements and non-functional requirements. So this is specifically talking about what the system needs to be able to do. Here's the difference. Functional requirements are functions that the system must perform. Okay. For example, you could say something like the system needs to allow the user to enter their name. Okay, the system needs to allow the user to enter in meals. The system needs to be able to randomize the meals and display them in a calendar format. Okay, those are all functional requirements. Non-functional requirements are, again, they fall into the category of what the system needs to do, but they're not related to specific tasks or features of the program. These are requirements related to usability. Okay, so you could say something like the UI needs to be set up in a colorblind mode. So if your user happens to be colorblind and can't distinguish between red and green, you might need to say, we need to use this particular color format. You could say something like the program needs to be able to run at a particular resolution, or it needs to be able to handle or needs to be able to run on an old iPhone 4 or something like that. So this is, related to reliability. So if you have maybe you're developing some sort of game and you say, well, the servers need to be able to handle 5,000 concurrent users, something like that. Those would be non-functional requirements. Performance, security. So if it's, again, a game, you say it needs to be able to run at a certain frame rate, or it needs to be able to support a particular graphics card, or whatever it is. If it's not specifically related to what the program does, it's a non-functional requirement. If it's talking specifically about a feature of the program, as far as a function that the program does, then it's a functional requirement. We're going to go over some examples, but are there big picture questions on these two? Okay. All right, so let's do these. The system must allow for the user to steer the car with the arrow keys. Functional or non-functional? Why don't you say it in chat? You can abbreviate it if typing it out is too strenuous for you. This would be a non-functional requirement, okay? And the reason it's non-functional is specifically related to this. It's talking about usability, or this would technically be an interface format. This is the way in which the user is going to interact with the program. Okay. Now, if it said the car needs to be able to turn, that would be a function of the program. But this is non-functional because it relates to how the user interacts with the program. Okay, and it's a subtle difference, but this is a non-functional requirement. The system must allow the user to log in. This is a functional requirement. This is something that the system itself must do. This is a functional requirement. All right, let's move on to number 3. The system's UI must be easy to read. Yep, this is a non-functional requirement. This relates to UI formats. So again, this is similar to like the colorblind mode I specified earlier. You could say something like, the person that I'm creating this for is really old and can't see well, so the font needs to be at least an inch thick or something like that. Okay. If you've ever taken your parents' phone and like the text takes up half the page or half the screen, you understand why this kind of stuff exists. Okay, next one. The system's AI for controlling the car must match up with the selected difficulty level. I would say that this is a functional requirement because it specifically relates to what the program is doing, not how the user interacts with it. This isn't a usability requirement. This is a function requirement. Like, so this is how the program needs to function. So number 4 would be a functional requirement. All right, let's go number 5. The system must be able to determine who is in first place at any point in the race. Functional or non-functional? Yeah, this is a functional requirement. Okay, again, doesn't have anything to do with usability, and it has everything to do with a feature or function that is happening inside of the system. Okay. Number 3 was non-functional. It dealt with usability. Okay, and specifically UI format. All right, last one. The system should display the current position 1, 2, 3, 4 of all the cars during the race. This one's tricky. We have some disagreement about this one. All right, here's my take on this one. I think one is better than the other. You could make an argument for either. I think this is a functional requirement, and here's why. This doesn't really relate to usability. This is, you could make the argument that the user is getting this information because it's related to UI, and and make the argument for non-functional there. But I think when you look at whether or not number 6, this right here, is more considered a function of the system, or is it more related to usability? I think it's more a function of the system. Again, you could make the argument either way, that this has to do with usability in the sense that the user needs to know what position they're in. But I think that's kind of outside the scope of what we're looking at here when we're talking about reliability. Now, if it says the font must be so big, or needs to be easy to see, or it needs to occupy this part of the screen or something like that, I think that's more on the non-functional side. But all it says is the system should display the current position. So to me, I look at that as a function of the system. This is what it needs to do. All right, so he says, so in general, is displaying information considered functional? Generally, yes. It's something that the system has to do. Now, if you're talking about how the system displays it, that's where it gets into non-functional. So if you're talking about the way in which it's displayed, color, size, font, that is more on the non-functional side. But if we're talking about just the fact that it needs to be displayed, that's a function of the system. So my logic was that if the display was decoupled from the internal logic, that it would just be a usability feature for the user to be able to see the positions. Yeah, and that's why I said you could. I can see how some people could argue this is a non-functional requirement because it's not necessarily related to the function of the game, something that it needs to do. But for the way I just explained it, I think this is more of a functional requirement than a non-functional requirement. And I put this one in there specifically because there are going to be times when there's some overlap between these. And it's not super necessary to make a huge distinction between these are functional and non-functional requirements. At the end of the day, this is what the program needs to do. And so having arguments over whether it's a functional or non-functional isn't really important. But it is important to understand that there are different requirements that you need to consider, things that the program needs to do, and ways in which the user is going to use or interact with the program. And those are kind of separate. Okay. Other questions on this? I know this can be tricky. Okay. And this is it. We'll finish up with this. So this is, like it says, common sense stuff. You need to prioritize requirements. And somebody mentioned this earlier with regard to, as you develop your program, how much do you need to stick to your original design? When you set up and you turn in your proposal, you should, if you don't, it's fine, but a good idea would be to kind of prioritize what you want the requirements to be. So here are the features that I plan to do. And maybe you put like optional next to some of them, or just prioritize them farther down the list. And like things that would fall under it would be cool if we did this type situation. Is a good way to do it. You want to make sure that you focus on the important stuff first. There's I forget what the quote is, but it's along the lines of 30% of the time spent working on a program makes 70% of the useful features, or something like that. And so you want to make sure that the time that you spend working on the system is building the important features. Okay, you don't want to spend 2 weeks, designing this really cool whatever could have just been as good if you had done something simple. Okay, so again, common sense stuff, prioritize. Have a discussion with the user about how the UI is going to look, how it's going to operate. what components you're going to use, input boxes, buttons, labels, drop-down menus, that sort of things. Again, you guys are doing real basic stuff. And then make sure you go over the requirements with the users. And so whoever's going to be doing it, you list these out and say, all right, this is exactly what we need, or exactly what the requirements of the program are. Am I missing anything? Okay. And that's about it. Questions on this stuff? Okay. Well, if there are no questions, here's what we will do. We finished earlier than I expected. And so what I'm going to do is our Thursday class, which is the 26th, we will, right here, we will still have it, but we're not going to cover any content. And so I will pop in and I will be here at 8:30 at the start of the class. And so these will kind of be like office hours. If you want to pop in and ask some questions, you can, but we're not going to cover any content that day. And so if you just need some time to work on your proposal, you want to take the quiz, whatever it is, you can use that time. We won't formally meet next Thursday. So next class period, we won't formally meet, but I will be here in the Zoom class if you want to pop in and ask some questions. Okay. And in fact, I'll post an announcement in Canvas because we're missing quite a few people, and just let them know the same thing. Okay. Anything for the good of the group before we finish up? Okay. Well, in that case, I will see you guys either Thursday or next Tuesday. And again, Thursday will be, call it a project day, although I will be here if you need me in the Zoom room. And then on Tuesday, we'll pick back up with content. Okay. Have a good one, and I will see you soon.
Thank you, Professor.
You are very welcome. And I'll stay in here for a couple minutes if you guys have any questions. I'm just going to put out the announcement.
Hey, Professor, can you hear me?
Yes, sir.
Okay, so I just had a few quick questions about the project proposal. How many sentences is that supposed to be? Like, I know you said it was supposed to be short, but is that like a paragraph?
It needs to be less than a page. I'm not going to be counting sentences or anything like that. You need to describe the program in enough detail that we have an idea of what it's going to do. And then you need to list out the function that it's going to do. And that doesn't have to necessarily be in sentence format. You could do it in bullet point format. So what makes the most sense is you to start it off with a written paragraph style description of what the system is. And that may only be 3 or 4 sentences, whatever it takes for you to accurately describe what the system is. You need to identify what the problem is that you're solving and that sort of thing. And then list what it's going to be able to do. You can do that in sentence format. You can do that in bullet format, whatever is easier. But if it only takes up half a page, that's fine, as long as you've accurately described in enough detail to make sure that we have a good sense of what it is that you're doing.
Okay. Also, this is a more like specific question to the project. I want to do it in C#, and from what I'm like seeing, C# is pretty similar to Java.
Yep.
So I don't think learning C# will be too much of a problem. But I also do want to do it with a GUI because I like don't really have much experience with a GUI, and so I just want to like get that experience now. Do you think it's too much to like learn GUIs, how to make a GUI and C# at the same time or anything like that?
No, it's super simple because C# is a .NET programming. So you're using all of the Windows forms and stuff that already exists. It's super simple. And so we'll try to look at some examples when we get into the next topic, which is C# object-oriented programming. So we'll take a look at Windows and all that sort of stuff. And I'll see if we can run through like some sample stuff so you can get the idea of it, but absolutely not. It's not too difficult to do. It should be relatively easy.
Okay. Do you know of any like resources online that I could try to learn something like related to GUIs on my own?
Let me see if I can find one. So I just did a really quick, I'm gonna post this in the chat. This is our YouTube video. I haven't really scanned the whole thing, but this is gets you started with Windows Forms in Visual Studio with C#. Okay, it's super simple. This is a 20-minute demo. And again, he covers the whole thing start to finish in 20 minutes. So it's super simple.
Okay. All right. Thank you very much.
You are very welcome. Let me know if you have any other questions.
All right. Sounds good. Thanks.